Hello, this is my second video on my YouTube channel, and today we'll discuss about the two terms, there's preload and afterload. As you have seen already that I have drawn the two separate sides of the heart. This is the right side of the heart, and this is right ventricle, this is right atrium, and here I have drawn the left side of the heart. This is left ventricle, and this is left atrium. So, as you have, first I will tell you something about little bit about the heart, little information about the heart. And as you have seen that here I have drawn this inferior vena cava and I have drawn the superior vena cava, and these are their opening ostias from which they bring blood into the atria. And after that, after atria, the blood will obviously come into the right ventricle. From right atrium, the blood will come and pool into the right ventricle, and in the diastolic phase of that ventricle. So in the diastolic phase of that ventricle, when the blood pools in this right ventricle, there is a little bit of tension produced in the walls of this tension, or there is a pressure developed in the ventricle, and there is a little bit of tension produced on the walls of the ventricle, of the right ventricle as well as left ventricle, when the blood comes from the lungs into the right ventricle, into the left ventricle. So at in left ventricle it is the same as in the right ventricle. So in right ventricle, as I was discussing about, that there is the stress or a pressure or tension developed in the myocardium, in the walls of the ventricle, and this load at the end of every diastole, when all the blood is pulled into the ventricle, the walls that experience the tension or the pressure, we can say, and this pressure or this tension is called the preload. So what is this called? This is called the preload. And as I have written here in definition that preload, a pressure which developed in the ventricles at the end of every diastole, and this pressure is it has direct relation. This pressure has direct relation with the end diastolic volume. That's end diastolic volume of the heart. That's all the blood which pools into that, and which pools into the ventricle during the diastole, and at end all the blood is pulled into the ventricles, and the pressure experienced by the walls of that ventricle is called the preload. As I have here also written that preload and end diastolic volume are always like, when end diastolic volume comes into your mind, preload should also come into your mind. So this is the preload. Now discussing about the Starling's law and law of heart. Starling's law of heart, it tells us that within the limits, it tells us that within the limits, the ventricular contractility depends on end diastolic volume. That is, and here we will draw a relation between the stroke volume and preload. So you have uh, heard about this definition, that's within the limits, that's not in pathological conditions but within normal physiological limits. The ventricular contractility depends on the end diastolic volume, and more the end diastolic volume will pull into the ventricles, more will be the ventricular contractility. That's more the stretch on the ventricular myocardia, and more will be the this forceful contraction or ventricular contraction. So, here we will draw a relation between the stroke volume and preload. You already know that stroke volume is a volume of blood that the ventricle passes in each, like a contraction or each pump. When a ventricle pumps, every time the blood that it throws out, that it pushes into our blood, into our other circulatory system, veins, vessels, this is called the stroke volume. Here we will draw the between the preload relation between the preload and stroke volume. As you have already seen that preload and stroke volume are Here is a definition. Here is a relation. There's stroke volume and preload are directly proportional. Oh, sorry. Stroke volume is directly proportional to preload. So I will tell you example. I will tell you, like, if here the preload in the ventricle, preload is the end diastolic volume. More the end diastolic volume, it means there is more blood in ventricles. This means that there is more stretch on walls. Ventricles. Walls of ventricles. It means that more the stretch of walls on the ventricles, there will be more forceful contraction. Forceful contraction of the ventricle to push that all blood that has come into it into our circulatory system. So this is the relationship between the preload and stroke volume. That's more preload, there will be the more stroke volume. That's every time our heart will pump more, but within the physiological limits. This was all about the preload. Now I will discuss about the same is the condition with the first. This same is the condition with the left ventricle. Here, right. Sorry. Here, right ventricle pushes the blood into the pulmonary artery. Pulmonary artery, and after that, into pulmonary trunk, then pulmonary arteries. This pulmonary trunk, this pulmonary arteries. Here, now the blood will go into the lungs to get oxygenated. Same with here, oxygenated, and after that the blood will come. The oxygenated blood will come and go into the left ventricle, and left ventricle via the left atria. First they will come into the left atria and then into the left ventricle. Same is the case when the left ventricle pumps and contracts, that it has sensed the load of the blood, that it has sensed the preload. Now it will try to pump that blood out of the ventricles into our into our aorta. So into our aorta, and same is the case with this has to pump blood. After the blood has pulled into the ventricle, it has to pump the blood into the lungs. Same is the case with the left ventricle. When blood has pulled, that's it has sensed its preload, that it has sensed its end diastolic volume. Now the ventricular wall will try to push that blood into the aorta, and same here will try to push the blood into the pulmonary arteries. Now these are pulmonary veins will bring blood into left side of the heart. Now I will discuss about the afterload. The afterload is like when our this ventricular myocardia will try to, like, pump the blood, contract. It will contract, but there will be an opposing force. There will be an opposing force to that contraction, to that blood flowing out of the ventricle. There will be opposition to that, and that opposition will be determined by the peripheral resistance. So this peripheral resistance, or we can say total peripheral resistance, this total peripheral resistance, and same is the case in right ventricle, and here we will call the, like, pulmonary resistance, and like what is the, yeah, or like what these lungs have, lung capillaries, or like little arteries have, like what they have produced their force of opposition to this blood going out from the right ventricle. So left ventricle, and so this left ventricle will like sense, like it will receive the opposing force from the total peripheral resistance, and this total peripheral resistance will help us define the afterload. This is called as afterload. Directly the pressure which will be Now during the pumping of that blood, due to this resistance, this peripheral resistance, there will be much more tension developed, or there will be pressure developed in the ventricular myocardia will try to generate that much of pressure which will meet its like pumping ability to pump the blood, like even if there is a resistance to it, even if there is peripheral resistance to that pumping blood, so the blood will go and will pull into will go and to our organs like brain, kidneys, GI system, all that. So here this total peripheral resistance have told us about the afterload. So simple, this is the simplest definition that I have told you, that I have made you understood what is preload and what is afterload. So here I will also draw a relation between afterload and stroke volume. Here, stroke volume is inversely proportional to afterload. Here I will make you understand this. See, whenever there is much more afterload, it means that there is much more total peripheral resistance. So during at this point, our heart will try to like contract, but the opposing force like total peripheral resistance or peripheral resistance will not make it do so, and it will try to decrease the stroke volume of that heart. It means that more the stroke volume, less will be the total peripheral resistance, or more the total peripheral resistance, it means that less there will be less stroke volume. That's our heart will not be able to pump all the blood against this total peripheral resistance. So this was the simplest definition. Now the main two important points that our student should remind every time whenever he is asked about these two terms, that's preload and this afterload. In preload, whenever he is told that there is a preload, and he should remember and diastolic volume. Whenever afterload is told, asked to any medical student, he should tell total peripheral resistance. So these are the two main points, and in from that you can like tell the whole story, that more the total peripheral resistance, more is the afterload, or less is the stroke volume. Similarly, here you will tell more is the end-diastolic volume, more is the preload, and more harder is the contraction according to the Starling's law of heart. Here in afterload, you can tell that Laplace law. This is the Laplace's law. Here you can tell the examiner or anybody who asks you that question, you can tell him that, as you know, that he will ask you, he will try to trick you people, that he will tell that hypertrophied myocardia, he will tell you questions like that, there is a hypertrophied myocardium, what is the after, and there is a normal myocardium, which will have more afterload or which will have more this less afterload. You can tell that this intra intracavitary ventricular pressure into, or the product of intracavitary ventricular pressure and ventricular radius divided by wall thickness of that myocardium is the tension produced in the myocardial fiber, So here you can see with the definition, you can solve these questions like like pro. So he will tell you that there is a hypertrophied myocardia, and there's a normal myocardia, and there is a hypertrophied myocardia, which will have more preload. As you can know that preload is the tension, so you can here tell him that with this definition you can tell that this wall thickness is more. As the wall thickness is more, so the tension developed will be less. Oh, sorry. Sorry for the mistake. So here I have done a mistake. There will be more tension developed in the myocardia because this is less. The tension will be more. Oh, sorry. I was right before. Less tension is developed in myocardia because the wall thickness is more. So you will tell that preload is less in. Sorry, you will tell that afterload is less in the hypertrophied myocardia. And this was all about this topic of preload and afterload. So please, if you like it, then encourage, then please comment.